In our previous lessons, we were solving absolute value equations. If you remember, we had to solve twice because absolute value is always positive. What fits inside the symbol could be either the negative or the positive. We move on to inequalities, and there's a couple different conditions, but it's basically the same type of setup. We're going to look at the ones that are less than and the ones that are greater than. In the less than, and don't forget that the C, or the number that it's compared to, has to be greater than 0. It's equivalent to the compound n type, and it's going to fit between the boundaries of a negative C and a positive C. In the second type, where the expression is greater than, we're going to say that once again it has to be greater than 0. And this time we're going to be looking at the n types, which should go in the negative C and the positive C direction. And that resembles the OR type of compound inequality we discussed. In that first transformation, the less than symbol cannot be replaced with a less than or equal to, but in the second transformation, we can either have a greater than or a greater than or equal to. The wording is a little bit hard to absorb at first, so let's put it to practice and it'll become much easier. We're going to start off with the and type, which means these are the less than. So when we look at these, we're going to start by rewriting it. We remove the symbol. We get the x plus 6 is less than 4. And if you recall, in the equations, we changed the sign. Well, not only are we going to change the sign as we rewrite it, we're also going to reverse or flip the direction of the inequality. And then we solve twice. We'll subtract 6 on one side. And in the first inequality, I'll have x is less than negative 2. And once again, we'll subtract 6. And we'll get x is greater than negative 10. When I want to write this as one inequality, because it's an n type, remember the variable goes in the center. So that we're looking at this first part saying x is greater than negative 10 and x is less than negative 2. Okay, so it fits in that boundary. Let's take a look at a second problem. Once again, we remove the absolute value symbol. We solve it once exactly as we see it. Negative 7 plus x is less than 5. And since it's a less than symbol, we do and. Negative 7 plus x, reverse the symbol and change the sign. Let's solve. The solving part is the same as we've done before. Isolate your variable. X is less than 12, and we'll add 7 again. And these could be two steps as well. X is greater than 2. So if I write this, I have my inequality in the center. I'm sorry, my variable in the center. This says that x is going to be less than 12 and x is going to be greater than 2. The more we do, the easier this becomes. In the second type, which is the greater than or the greater than or equal to form, we're going to once again solve twice, except that this is going to be going like a compound OR type. X plus 6 is greater than 12, or x plus 6 reverse is less than negative 12. Reverse and change the sign. Subtract 6, and you get x is greater than 6, or let's subtract 6. X is less than negative 18. Again, you'll see they're going in opposite directions, but we're solving two inequalities because these are absolute value. We'll remove the symbol. X plus 1 is greater than or equal to 3, or x plus 1, reverse the symbol, change the sign. Subtract 1, x is greater than or equal to 2, or subtract 1, x is less than or equal to negative 4. So you want to start off by remembering you're going to reverse your symbol and change your sign. Then you have to look at which type it is. If it's the less than symbol, then we're going to get the or, the and type of situation. If it is a greater than or equal to, it will be the ors going in opposite directions. We'll just take a look at one or two more problems. I did put in a two-step here so that we could see it's the same process. This is a less than symbol, which is an and type. I've got my 2x plus 10 is less than 8. That's one possibility. And then I have my and 2x plus 10. Reverse the symbol, change the sign. Subtract 10 on both sides. 2x is less than negative 2. Divide by 2. I get x is less than negative 1. And because it's a less than, it's an n type. Let's subtract 10 on both sides. I get 2x is greater than negative 18. And divide by 2. And we get x is greater than negative 9. We write that as a compound inequality with the x in the center, and we get our x is greater than negative 9, and x is less than negative 1. Let's look at one more of the or type. When I see the greater than, it's going to be the two separate with the or. We'll get the 2x, it's a two-step again, is greater than 4, or 2x minus 8 is less than negative 4. Change the sign and reverse the inequality. Add 8 to both sides. You get 2x is greater than 12. Divide, and x is greater than 6. Or we'll add 8 once again. We'll get 2x is less than 4. Divide by 2. And x is less than 2. Again, going in opposite directions. If you were to graph this, we'd have open circle and shading to the left for 2 and shading to the right for 6. There are two more here. We'll go over a couple more in class. And again, like I said, after we do a little bit of practice, these will come much easier. We'll do more in class.